From a security perspective, knowing port numbers is a pretty important thing. A lot of the technologies that we use to filter out traffic or to firewall traffic on our network uses port numbers as one of its primary mechanisms. There are a number of different things to look at for port numbers. With IPv4, we're really examining TCP port numbers and UDP port numbers. So if you look at a server IP address, there's going to be a server application port number associated with it. If you look at an HTTP server, a web server, there's going to be a TCP port 80 that is used to provide those web services. On the client side, there's also a port number that's used to communicate to the server. So when the server responds to the client, it not only responds to the client with the IP address of the client, but also the port number that was used to initiate that conversation. So when the client receives the response, it knows what the response was to. There are also things to consider with the port numbers that are being used. There's something called non-ephemeral ports or permanent port numbers. Ephemeral means the port number is temporary. So non-ephemeral means that it's a permanent port number. These are port numbers that are assigned to a service. A web server uses port 80. That port 80 is a non-ephemeral port. Now, obviously, that means there are ephemeral ports as well. There are port numbers that are just used temporarily. You usually see this on the client side. The client picks a number, and that's the number that that client uses as the port number during that flow. When the flow is finished, it uses a different port number to be able to start another flow to that same server. So you'll see a client opening up a single web page may go through 6 or 7 or 10 or 15 different port numbers as different flows are opened and closed to that particular web page. Whether it's a TCP port or a UDP port number, it's usually a number that's going to range somewhere between 0 and 65,535. When we're discussing port numbers on a server, usually it is this non-ephemeral port number that we're talking about. It's that port 80 that's never going to change. It's always going to be port 80. Now, web server doesn't necessarily have to run on port 80. You could configure your web server to run on port 300. You can configure your web server to run on port 65,000, and people would need to know that port number to be able to communicate with it. That's one of the advantages of using these non-ephemeral, these permanent port numbers, is you almost always assume that a web server is going to be on port 80, but it's not always the case. If you wanted to put it somewhere else, it's certainly available for you to do that. It's just a number, and it's something that you can assign yourself. Port numbers are only used for communication, not security. Just because I put a web server on port 300 doesn't make it any more secure. Maybe it hides it a little bit, but there's some very easy methods for determining what port numbers are open and available on different servers. So it's only something that you're using to sync up your browser with a web server. Really not something you should use to be able to try to hide a particular service or a particular server. Most service port numbers then need to be well known. You need to know that a web server is going to be on port 80. You need to know that encrypted traffic to the web server is always going to be on TCP port 443. Those are things that really help you if you want to make those services available to other people. Another thing to keep in mind is that port numbers for TCP are a completely different grouping of port numbers for UDP. They are both using numbers between 0 and 65,535, but TCP is a different protocol than UDP. You could have a TCP port 80 made available on a server and a UDP port 80, and those two protocols could be providing completely different services on that server. If you were to look at the packets that were going between a client and a server, you would see something like this. Your computer is over here on the left side, 192.168.0.5 is its IP address. And then there's a web server, maybe out on the network, that is 192.168.0.10. So at least we know the IP addresses that we need to communicate between. On the web server, there are some permanent or non-ephemeral port numbers, UDP 53, TCP 80, TCP 443. And if you really looked into it, you would see that UDP 53 is used for name services. We would see that TCP 80 is probably used for our web server, and TCP 443 probably also used for our web server to send the encrypted data back and forth. If I wanted to set up a session to this web server over TCP 80, my computer behind the scenes would automatically pick a port number. Maybe that port number would be 1331. It would need to be TCP because I want to communicate to the web server over TCP. And I'll tell the web server, hi, I'd like to see your homepage, please. And I'm going to do that over port 80. that web server receives that request, it's going to send the response back, and it's going to send the response back to 192.168.0.5 TCP port 1331. If I look at that page and I decide to click something on that web page, my machine starts another session, a new flow that would probably be TCP port 1332, talking to TCP port 80, and the whole process repeats itself again. No matter what you're looking at on a server, there's going to be port numbers that are available to end users. And if you look at the client computers, they're always using a source port number to initiate that flow.